This one goes out to everyone taking chemistry for the first time. Stoichiometry is incredibly overwhelming when you're first exposed to it, and then when you throw solutions into the mix, it gets so much more complicated. But spend 2 minutes with me going through an example problem, and hopefully you'll feel more confident with this. So in this problem, we're going to have 2 aqueous solutions, which we're going to combine in a precipitation reaction. So that means it's going to be a double replacement reaction where we are forming 2 products, one which is another aqueous solution and one which is a solid. So we're given the volume and the concentration of each. The first thing you always need to do with stoichiometry is write out your balanced equation. So here I'm just figuring out what those reactants are going to be, just using all of the techniques that you learned when forming ionic compounds. And then this is a double replacement reaction. So basically potassium and lead switch places, giving us potassium nitrate and lead 2 iodide. So now we need to think about the states of our products. Easiest way to remember solubility is just focus on what's always soluble. So group 1 ions, nitrates, acetates, and ammonium, always soluble. Therefore, KNO3 is our aqueous product. The lead 2 iodide is our solid. So now that you have your chemical equation with states, make sure it is a balanced equation. So when we're doing stoichiometry, we're going to be looking at comparisons between any 2 reactants and products. So now what I'm going to do is I'm going to pull the information that I know from the problem, and I'm going to put it directly under each of those reactants, just so I can keep things organized. I'm going to put what I'm looking for under the PBI2, which is the mass of the solid precipitate. So what we're going to do first is we need to always convert into moles. I can't make comparisons between 2 substances unless it's on a moles to moles basis. So you're going to use the equation MV equals moles, where it's the concentration times the volume in liters will give you the number of moles of each reactant. So now that we have moles of each reactant, we're going to figure out which of those is the limiting reactant. Which one is going to limit the amount of product that we make? So the easiest way to do this is just to use those mole ratios. So I'm looking at Ki first. For every 2 moles of Ki, I will make 1 mole of PbI2. So I'm just going to divide my moles, divide by 2 will give me my predicted moles for lead iodide. Then we have to do the same thing with the other reactants. We don't know which one is going to limit this reaction. The good news is the process is identical. You're just going to convert from moles of the known reactant into moles of product. Then we're going to see which one makes less. So in this case, Ki makes less. That is our limiting reactant. That means the lead 2 nitrate is in excess, and we don't need to worry about it again. So now we're going to take our moles of PbI2 from the Ki, and we're just going to convert that from moles into grams, because that's what this problem is asking for. So to do that, anytime you start with moles, you're going to multiply by that molar mass. This is going to give us a final answer of 4.45326. But of course, at this point in the year, your teacher is bothering you about sig figs. So let's go back to those original values. All of those have 3 sig figs. Your final answer also needs 3. I hope that was helpful. Check the link in my bio for a free stoichiometry chart to help you sort through all of this. Hang in there.